algebra students, Mr. Lawrence here, and we're going to learn how to simplify radicals. It's going to require breaking things down into prime factorization or into factors that are perfect squares. I'd rather do perfect squares if I can, but if I can't, I'll do prime factorization. Before I do this, I want to make sure I'm good at knowing my perfect squares. I really encourage you to have memorized these if you haven't already. I mean, 1 is a perfect square, 4 is a perfect square, 9, 16, 25, 36, 49, where are we at? 64, where am I at? That's 8, that's 9, 81, 100, 121, 144. Now, most of you should know these pretty easily. By the way, hi Ashley. Okay, 144 is called a gross. Anyway, you should be able to do these through 144, through 12 squared, no problem. Now, all you have to learn is from 13 to 20. Well, Jiminy Christmas, 20 squared is 400. How hard is that? Okay, so it's going to end in 400. So now you only have to learn 13 to 19. It's pretty easy. 13 squared is 169. Okay, you know 3 times 3 ends in 9, right? Okay, so it's 169. And then 14 squared, all you have to do is 196. Change the 2. Okay, 15 squared is 225. Okay, it's got to end in 5, right? 16 squared, that one always gives me trouble. I really don't know why. I think I've learned it pretty well right now. But over the years, it's just always giving me trouble. It's the one I get stuck on. 17 squared is 289. And 18 squared is 324. And then 19 squared is 361. Now, all you need to do is memorize the ones you don't know. These first 12 should be cake. Oh, I didn't want to use a crayon there, excuse me. Oops, wrong button. Okay, so let me get it off that crayon there. So these 3 should be real simple. So in actuality, you have 1, 2, 3, 4. One of them that should be, well, maybe a little bit challenging, maybe. All right, look, 19 times 19. Well, it's going to end in 1, right? That helps me remember. Okay. 18 times 18 is going to end in 4. So you see, there's my 4. And then 17 and 17 is going to end in 9. So notice they kind of go up. 19, 22, 25, 28, 31, 36. Well, I just noticed that. Look at these. The tens digit. Oh, I'm sorry. If I look at here, the first 2 digits, it's 10, 12, 14, 16, and then it starts to go by 3s. Right, and even went by 2s here if I count that as 81, right? And 64 and 49. So these are all going up by 20, if you will. It's not really 20, but that part of it. So anyway, then it starts to go up by 3. So see 19. 22, going up by 3 to 25, up by 3 to 28, and then it starts to go by 4s, and it keeps going by 4s. It's interesting. I've never noticed that before. Okay, so I'm going to suggest you memorize these. Now, when I go to simplify a radical, oh, by the way, a radical is the positive version of the square root. That's what a radical is. It's the positive of the square root. So, like if I ask you the square root of 9, you're going to tell me 3 or negative 3. If I ask you for the radical of 9, you're just going to tell me 3. Now, the symbols are 100% identical. You can't tell unless you listen to the question. But when I'm going to do this, I'm going to break it down into factors. Whenever possible, I'm going to pick a large perfect square factor, if I can. Now, 9 breaks down into 3 times 3. And I like to think of the square root symbol or the radical symbol as being a house. And whenever I have a matching number, they can go out on the date. They can leave the house. And then any numbers that are left behind are stuck in the house. Now, in this case, there are no numbers left behind, so I don't bother to show the house. The 3s are out on one date having a good time. Okay, I'm going to do 36. I'm not going to go all the way down to its prime factorization because I'm going to get 6 times 6. I'm going to get a matching pair. The 6s can go out on one date, and there won't be anybody left in the house. Okay, this one here, 40. Well, I'm going to break down to 4 times 10, and I know 4 is the same as 2 times 2. Well, these 2s get to go out on a date. The 10 I could break down to 2 and 5, but there's nobody there to date. They're going to be left at home washing their hair. So these 2s are going to leave the house, go out on a date, have a good time. Meanwhile, the 10 is stuck at home because he doesn't have a partner to go on a date with. Okay. Now, by the way, you can't go on a group date unless you're talking about like cubed roots or maybe fourth roots. Okay. If we're doing those, like the cubed root of, say, 54, well, I need 3 matching numbers. For example, I could rewrite 54 as 3 times 3 times 3 times 2. Well, these 3s could go out on a group date, and there'd be a 3 out front, and the 2 would be left at home washing his hair because he doesn't have 2 other partners to go with on the group date. But when we're simplifying radicals, we're only talking about pairs. And so I'm going to break 200 and down to 10 times 10 times 2. Well, the 10s will go out on one date, and the 2 will be left at home. Okay, 72. Let's see here. You might think 9 and 8, but I'm thinking 2 and 36, because 36 has factors of 6 times 6. These will go out on one date. I'll have 6 rad 2. Now I'm going to do this one a different way, doing it the 9 way, the 9-8 way. I'm going to show you how it works there. Okay, so I'm going to have 9, I'm going to have 8, and I know this is 3 times 3. Oop, got a date. Got a pair of 3s out on one date. And then I'm going to have a 2 times a 4, and that's going to break down to that. Now the 2s get to go on a date, right? Now they're out front also. It's not 32 out front though, it's 6. Now who's left at home without a partner? The 2. The 4 is not, because he's broken down into 2 times 2. So your simplified radical is 6 times this radical of 2. 6 rad 2, we like to say. That's a longer way to do it. I like it better the first way I did it because I grabbed the largest perfect square. Now here you may not know the largest perfect square, but seeing a 75 there, I'm guessing 25 is going to go in. And how many times? Well, 4 would be would be 100. Okay, so let me see here. Losing my logic. 25, if I have times 4, that's 100. If I want 600, I'm going to have to take multiply by 6, so 24. But I don't want 24. I don't want 600. I want 675. So I'm going to need 3 more. So I'm thinking 25 times 27. Oops. Times 27. Let's see, does that make sense? If I have 27 quarters, yeah, I'm going to be just short of $7. Yeah, that's right. Now this breaks down to 5 times 5. Look, I got a date. Okay, and here we've got 3 times 3 times another 3, right? So there's another date. So the 3s leave the house on a date. The 5s leave the house on one date. This 3 here is stuck at home washing his hair. So my simplification is 15 rad 3. And there we go. That's going to help us when we're doing our square root problems. When we have, say, x squared plus 6x plus 4 equals 0. Okay, and so when I go to find my discriminant, remember it's A, B, C. Easy as. I lost it. Sorry, I have a mental blank. 1, 6, 4. Okay, when I go to do my quadratic formula, I'm going to do my discriminant first, which is the b squared minus 4ac part. And that's going to be what? 6 squared. Getting ahead of myself, sorry. 6 squared minus 4 times 1 times 4. So I'll get 36 minus 16, which ends up being 20. So when I go do my quadratic formula, x equals the negative of b plus or minus the square root of b squared minus 4ac all over 2a. So when I do that, I'm going to get negative 6 plus or minus the square root of the discriminant, and that'll be over 2. Okay? Now, to simplify this, simplifying does not mean press the buttons on calculator. That's to find an approximate answer. I'm looking for the exact answer. So I'm going to get negative 6 plus or minus, I've got to break down this rad 20. Well, I know 20 is the same as 4 times 5. And these 4's can break down to 2 times 2. 2's can leave the house on a date. So I'll have 2 rad 5. Okay, that'll all be over 2. Now this still isn't simplified. How do I know? Because I know that this 2 in the denominator divides into the negative 6, but it also divides into this 2 here. So the simplest form of my solution is this. 2 divided by this negative 6 divided by 2 is negative 3 plus or minus, those 2's cancel, rad 5. And there is the simplest exact answer. Okay, why is an exact answer important? Because there are times when rounding just doesn't make sense. It changes your information. Okay, so we need to be able to deal with both the exact answer and the approximate. I'll do one more of these. And so I'll go find the discriminant. I've got 5x squared plus x minus 3 equals 0. So A, B, and C, easy as 5, 1, negative 3. And then we're going to do the discriminant part, b squared minus 4 AC, which is 1 plus 60, I believe. Right? 61. And so x will equal negative of b plus or minus square root of 61 over, lost my place, 10. Now, 61 is prime. It won't break down, and 10 and 1 don't simplify, and there's nothing there to simplify. So this is the simplest answer. Okay? What if it looked like a couple of these? So here we have 2 cases where I've already given you the the solution, but they're not simplified. So we're going to simplify this rad 28. So we're going to have 8 plus or minus, and let me see, rad 28, I think it's 4 times 7. I get a pair for a date, and so we're going to get 2 rad 7. That'll be over 10. Only going exact answers here. So now I have to simplify. I have to simplify 8 tenths, and I also have to simplify the 2 tenths. And what I end up getting is x equals 4 plus or minus square root of 7 over 5. Right? Because 2 divides into all 3 numbers. Okay, how about this one? I got negative 6 plus or minus, it's over negative 8, and I got to figure out 288. Well, how about 144 times 2? That'll break down to 12 times 12. So 12 rad 2. All right. What's the biggest number That goes into this one, and this one. I'm thinking 2 will go into -6 3 times. It'll go into 8 4 times. It'll go into here 6 times. Now, an interesting thing, I can also cancel these negatives. But you're saying, but Mr. Lawrence, does it cancel here? Well, it would cancel with both, which would have this effect. The plus minus would turn into a minus plus, and really it's the same exact thing. If I do 5 plus or minus 1, isn't that the same as 5 minus or plus 1? Yeah, so I can go ahead and cancel these plus signs. And my simplified version of the exact answer will be 3 plus or minus 6 rad 2 over 4. Now, some of you may want to go ahead and simplify here. If you do that, you have to break this into 2 problems, 3/4 plus or minus, and then the simplified version, which I would not recommend doing. I think it gets more complex. This won't simplify because the 2 that would go into both 6 and 4 does not go into the 3 evenly. Excuse me. All right. Anyway, that's it for this. Simplifying radicals, this is just to help us understand how we're simplifying our square root answers or our quadratic formula answers. All right, Mr. Lawrence signing off. Have a good night, everybody.